you have to do is you've got to balance the number of electrons lost and gained, and you've got to make them equal. You can just hold on 1 second. So so just give me 1 second. Let me copy one equation. So N2O plus H plus 1, and it's forming I2 plus NO. Plus H2O. So that's the reaction. So we're gonna try and balance this particular equation. Take the one over here. Just 1 second. I have to remove this. So we're going to try and balance this equation. And the first thing is, whenever you have a redox reaction, the very first thing is you have to balance the number of electrons gained and lost. And you can only find that you can only do that if you know what the charges are. So first thing is IO3 minus 1, find the oxidation state of IO3 minus 1. I is unknown, that's X. You know oxygen is minus 2, that's times 3. And the total charge on the entire thing is equal to minus 1. So if you solve for this, I think X comes out to be equal to plus 5. So it comes out to be equal to plus 5. So that means I over here is plus 5. What is N over here in N2O? So you're going to try and find N2O. So N2O is, N is unknown. So that's X, and there are 2 of them. So 2X, oxygen is minus 2. And the entire thing should add up to be equal to 0. It's a neutral molecule, so it should add up to be equal to 0. You solve for this, it would come out to be equal to plus 1. So that means N over here is plus 1. And then you've got iodine. Iodine over here is 0. N is obviously, I mean, oxygen is minus 2, so N must be plus 2 because it's a neutral molecule. So we found the oxidation states of all the elements. That's the first thing that you have to do. And once you've found that, figure out who's gaining electrons, who's losing electrons. So what's happening to iodine? Plus 5 to 0. क्या हो रहा है इसके साथ? Gaining or losing electrons, and how many?
Reduction.
ठीक है, that's reduction. It goes from plus 5 to 0. So that means it gains 5 electrons. So reduction is happening. What's happening to N? N goes from plus 1 to plus 2. So that's a loss of 1 electron. So remember, what you have to do is you have to make the number of electrons gained and lost equal. That's the first thing that you have to do. So for that, what you can do is multiply this by 5. All you have to do is you need 5 nitrogens, sorry. Then the number of electrons gained and lost would be equal. Because I need to make the number of electrons gained and lost equal. So I multiply this one by 5. So what that basically means is that I should have 5 nitrogens. Now, making this 5 nitrogens is kind of difficult because I would have to multiply this by 2.5. So I'll go into decimals. I don't want to actually go into decimals because equations are always balanced in whole numbers. So what I can do is I can redo this. Forget 2.5, forget this 5. Think of another number, multiply both with that number. So let's say I multiply this by 10 and I multiply this by 2. I'm doubling the numbers. Previously I was multiplying it by 5. Now I'm multiplying it by 10 and multiplying this by 2. So now the number of electrons lost and gained would also be equal. So that basically means that I should have 10 nitrogens. So that is easy. That would give me a whole number. So 5 N2Os, that's 10 nitrogens. And there's going to be 10 nitrogens over here as well, so that's 10 NO. And iodine needs to be multiplied by 5. There should be 2 iodines. So multiply this by 2. And over here, there are 2 iodines already. So that's 2 already. So the number of electrons gained and lost equal, that's a mandatory step. Without this, you can't balance an equation. Like you can try balancing it, hogi nahi, theek hai? It's very hard to actually balance a redox equation by the normal way. Theek hai? You have to make the number of electrons gained and lost equal at all cost. So this one is, now the equation looks balanced. I mean, at least electron wise, the ones that I'm underlying, don't change the ratio now. This part is balanced. Okay, is this clear? Izan, is this clear? The list, Oswa, is this clear? Saad, Mahad is. Yes, so now the number of electrons gained and lost are equal. The only thing you have to do is you have to balance what's left. Balance H and balance. Ye aapne balance nahi kiye the, so you just have to balance these now. So you've got, what you can do is you can count the oxygens. That's 5 plus 6, that's 11. So that's 10 plus 1, that's 11. So that's already balanced. Yeah, you can balance the hydrogens. That's 2 of them. So there should be 2H plus 1 ions over here as well. So now the equation is balanced. So make sure balance the number of electrons gained and lost, make them equal. So before moving to the moles question, we'll do some more practice with this. Let me just copy one more equation from here. I'm not really sure how many we did already. Okay, let's copy one from this one. So let's copy. So I've got MnO4 minus 1. It's reacting with C2O4 2 minus. And there's H plus 1 involved as well. And with that, you have the products, which are Mn2 plus and CO2. And there is H2O as well. So I've copied the equation. I'll just, 1 second. Afeen, how did I balance the oxygen? That was easy because, I mean, the things that I've underlined, I mean, I'm not going to touch them, okay, because the ratio of the number of electrons gained and lost would change. So I'm not going to, I've already balanced that. So there are 6 oxygens and there are 5 oxygens. That's 11 oxygens on the left side. So I need 11 oxygens over here. So that's 10 oxygens and there's 1 oxygen. So that's already balanced. So I don't need to balance that. Afrin, is this clear? So let's do this next equation. Now I've got first thing, find the oxidation states. MnO4 minus 1, that's the first one. So that would be X, that's Mn. Oxygen is minus 2 times 4. And the total charge is equal to minus 1. So X, if you solve for X, it should come out to be equal to plus 7. So Mn over here is plus 7. Oxygen is minus 2. What about C2O4, 2 minus? Find C2O4, 2 minus. C2O4, 2 minus, that means carbon is X, 2 of them. Oxygen is minus 2, there are 4 of them. And the total charge is equal to minus 2. So help me with this. If I take the minus 8 to the other side, it will become plus 8. 8 minus 2 would give me 6. And then I'm going to divide by 2. So that will give me 3. So X comes out to be equal to plus 3. So that means carbon over here is plus, it's plus 3. I think it's +3. Okay, make sure double check this. Mn here is obviously +2. That's already given. CO2, the carbon would be +4. You can solve this. Carbon would come out to be, it will come out to be +4. So this one is coming out to be +4. Now you've figured out the oxidation states of all the elements in the equation. All you have to do now is who's getting reduced and who's losing electrons, who's gaining electrons. So Mn goes from +7 to +2. So that means it gains 5 electrons. It's getting reduced. Its charge is getting reduced. Carbon goes from +3 to +4. Remember, the oxidation state is for one of the atoms. So that means one of the carbon is going from +3 to +4. That means it lost how many electrons? 1 electron, actually, just one. So I need to multiply both by, one of them by a certain number. One example is I can multiply this by 5, which basically means I can have 5 carbons, and the electrons gained and lost would be equal. Now, if I want to make this 5 carbons, I would have to go into decimals. I would have to write 2.5 over here. TK, which I don't want to. I don't want to go into decimals. So what I'm going to do is I'm going to think of some other number. TK, double that. Multiply that by 10. And multiply this by 2. Even then, the number of electrons gained and lost would be equal. So that means I should have 10 carbons. So this would be 5C2O4 2 minus. That will give me 10 carbons. And there should be 10 carbons on the other side. That's carbon dioxide multiplied by 10. So that will give me 10 carbons. And I'll have the Mns are going to be, I need 2 of them. So 2 Mns and 2 Mns over here. So I need 2 Mns. 2 over here and 2 on this side as well. Is this clear? Mahad, is this clear? Izan, Wafa, is this clear? Oswa? Yes or no?
Yes, sir, it's clear.
So that part is done, and you can just move to oxygen now and hydrogen now. That's the last thing. So you've got a lot of oxygens. That's 8 plus 20. That's 20. You've got 28 oxygens over here. So remember, the things that you've already balanced, don't touch them. Don't mess them up again. So these things are already done. Don't even touch the ratios. I said 8 H2Os, just a second, 28 oxygens over here, right? So that's 20. So you need 8 H2Os. So that is 8 H2Os. And you'll have how many H plus 1? You'll have 16 H plus 1 because there's 16 T chemicals here. So there's going to be 16 H positive ions on the other side. So that's your balanced equation. So we're done with balancing equations. All you need is more practice. You need to practice this a lot. How to balance redox equations. Usually you just get a 1-mark question on this, like questions that deal with balancing equations, like straightforward questions. That's just 1 mark, usually 1 or 2 marks. But a lot of times what happens is the balancing is followed by a moles question. So if you get the ratio wrong, you get the whole moles. Most of the answers in your moles questions will come out to be incorrect. So a lot of things would depend on how you balance the equation, especially when it comes to a moles question. Now, there's one more type of reaction, and that's called a disproportionation reaction. Just remember, although this part is complicated, but directly speaking, you don't get a very big question on this. But indirectly speaking, it will matter a lot, especially when it comes to moles, because everything depends on the ratio. You got to find that correct ratio. I said now you've got you've got another type of reaction which is kind of the same thing. It's called a disproportionation. So that one is called a disproportionation reaction. What happens in disproportionation is that the same element gets oxidized as well as reduced. And reduced. So they're not two different elements, but the same one. An example for that is this equation. It's NOH reacting with Cl2, and it ends up forming NaCl plus NaClO3 plus H2O. Okay, that's one reaction. Now, remember, redox equations are really hard to balance in the normal way. I mean, most of the time they're not going to get balanced. Even if they are balanced, you're not going to balance them correctly. Because until the number of electrons gained and lost are not equal, the equation is not going to be balanced. So you've got this reaction, and you have to balance this. First thing is finding the oxidation state. So Na is +1, O is -2, H is +1. Cl over here is 0. Cl over here is -1. Remember, Na is not changing oxidation state, so I'm not writing its oxidation state. Na is +1, Na is +1, Na is +1. Na is group 1. Group 1 is always, it's always +1. So forget Na, we're just ignoring it. What is Cl over here? Na is +1. Cl is unknown, oxygen is -2, and there are 3 of them. So you make it equal to 0 because it's a neutral molecule, and X comes out to be equal to what? I think it comes out to be equal to +5. So you got a Cl which is +5 over here. As I so forget the working. So we figured out who's getting oxidized and who's getting reduced. Cl is the one that's getting reduced, goes from 0 to -1. And that indicates it gains how many electrons? It gains 1 electron. Cl is the one that goes from 0 to +5 as well. So that is oxidation. That means it loses how many electrons? It loses 5 electrons. So this one is a disproportionation reaction. The same element is gaining electrons, and the same element is also getting reduced. Both things are happening at the same time. But you're going to do the same thing. You need to make the number of electrons gained and lost equal. So what you're going to do is you're going to multiply the first one by what number? By 5, which basically means that you should have how many Cl -1 ions? You should have 5 of them. So you should have 5 of them. Then the number of electrons gained and lost would become, it's going to become equal now. So there should be 5 Cl -1s, and there should be just 1 Cl +5. So that means the total Cls that I have at the start are 6. That means you've got, at the starting point, you have 3 Cl2s. 5 of them turning into Cl -1, 5 of them gaining 1 electron, and 1 of them losing 5 electrons. So that's 1 of them losing 5 electrons, 5 of them gaining 1 electron. So that gives you a total of, at the starting point, there would be 6 Cls. But we did the same thing. Cl -1 was gaining 1 electron, +5 was losing 5 electrons. So I multiplied that by 5, which basically meant that I should have 5 Cl -1s. So is this clear? Saru, clear? Can you read? Is this clear? Sidra? Mahad?
Yes.
Izan, is this clear? Afreen? Amna, is this clear?
Yes, sir.
अच्छा बाकी रह गया कि the last part is कि you have to balance I mean how many NAs do you have? You've got 6 NAs, so that's going to be 6 NaOH, and you can balance the last thing, which is water. That's 6H, so there should be 3 H2Os, and that's it. So that is Afrin, इस केस में मैं फिर से explain कर रहा हूं. I'm doing the whole thing again. One second. नहीं ये तो ठीक था. अच्छा, so Afrin, is this clear that CL, the starting point is CL? Like forget the 3 over here. Both CLs, some of the CLs are turning into CL minus 1, some of the CLs are turning into CL plus 5. Is that clear that some of them are gaining 1 electron to turn into CL minus 1? Some of them are losing 5 electrons to turn into Cl plus 5. The number of electrons, the number of electrons gained and lost must be equal. So that means kisko kisse multiply karna? How do I make the number of electrons gained and lost equal? I'm going to multiply this by 5. I'm going to multiply this by 5, which indicates there should be 5 Cl minus 1s. Afrin, is this clear? So the point is that if I have 5 Cl minus 1s, तो मसला खत्म हो जाएगा कि it'll be gaining 1 electron, but you've got 5 of them, so that means the total electron gained would be 5. And you just need 1 Cl plus 5. So I'll just multiply this by 1. I'll keep it 1. Like I'm not going to change it. So I'll just need 1 Cl plus 5. So that would do the job, one of them. Okay? So what is the total amount of Cls I've got? I've got 6 of them. So starting point the wahi tha na, so that means all of them, the starting point is the same. So there's 6 of them. So this would be multiplied by 3. So you had 6 Cls at the start. 5 of them gained 1 electron each. So, and 5 of them became Cl minus 1. And out of the 6, 1 of them turned into Cl plus 5. Okay, so the number of electrons gained and lost is now equal, and you can just balance the NaOH and the water 6 NaOH, and you'll have 3 water molecules. Okay, so is this clear? Afri, is this clear? So we're going to move and turn towards moles questions now. Okay, that's what we were trying to do. We're going to do moles and redox questions now. And 1 second, where's the moles worksheet? This one. So we're going to do the same moles worksheet, but we're going to focus on the redox part now. So for example, let's do the titration questions, which are redox and titration. So there's some straightforward redox equations. There would be some where they'll ask you to balance them. For example, let's focus on this one. Sometimes what they'll do is they'll just separate the equation. Sometimes what they'll do is that they'll write the reduction equation separately and the oxidation equation separately. Let me explain this. I mean, for example, if you have a simple redox equation like this one, like Na is reacting with, I mean, like a very simple equation. Na is reacting with Al3 plus, and it's turning into what? Na plus 1. and Al. So instead of actually drawing these arrows where I said that Al3 plus gains 3 electrons, right? And Na loses 1 electron. I mean, we did that, right? And then we made that equal. Sometimes what you can do is you can just separate it. For example, the reduction part, you can write it separately. Like Al3 plus is gaining. I mean, I like shortcuts. I like to do the whole thing on the same thing. TK, I don't want to write two, like make my work longer. So, but sometimes they're going to refer to this like this, like Al3 plus is turning into, I mean, you've got Al3 plus, it's turning into Al. So Al3 plus is gaining 3 electrons and forming Al. So that's my reduction equation. And my oxidation equation is, I've got Na turning into Na plus 1. So Na losing 1 electrons, and it's turning into Na plus 1. So it basically lost 1 electron. That's my oxidation equation. So I can split the equation into 2 parts. One of them is reduction, the other one is oxidation. I can do this for every equation, but it's going to be just time consuming. So I don't need to actually do that. I can kind of do the working on the whole thing. I don't want to do this, TK. So you can do this. And then you can balance the number of electrons. Like over here, what we did was we just did things directly. You just need to multiply Na by 3. And the number of electrons lost and the number of electrons gained would become equal. So you just have to multiply this by 3. This other thing, it's kind of the same thing. Multiply Na by 3. And the number of electrons that are being lost and the number of electrons that are being gained would become equal. Is this clear? This thing. You clear this? Amna, is this clear? Izan, Mahat, is this clear?
Yes, sir. It's clear.
And then you can sort of add them up. You add up the reactants. What are your reactants? Your reactants are Al3 plus. And your reactant is add the left-hand side and add up the right side as well, the product side. You got Al and 3Na plus 1. Okay, so you can just add up the reduction and oxidation equations and you'll get your redox reaction. But there's no need to do this. You can actually do the working on the entire equation. That's it. I mean, all you had to do was multiply Na by 3. So it's just time consuming. It's just a waste of time to actually think of the equation as 2 separate reactions and then combine the 2 reactions to form this overall equation. So you're just wasting time. All you have to do is Na was losing 1 electron. You multiplied by 3. So the number of electrons gained and lost became equal. But always remember, whenever you're given reduction and oxidation equations separately, all you have to do is make the number of electrons gained and lost equal and just add them up. Add up the reactants, both reactants in both equations. And you simply add up the products and you'll get the overall equation. So this is what we're going to do over here. He gave us reduction and oxidation equations separately. The first thing is I need to make the number of electrons gained and lost equal. So I can only do that if I multiply Fe by 6. So I'm going to multiply Fe by 6. So the number of electrons gained and lost, the number of electrons gained over here in reduction, and the number of electrons lost over here are now equal. And he's saying using the half equation to write an equation for the reaction. So you just add them up, add the 2 equations up, add up the reactants. What are your reactants over here? These are your reactants, Cr2O7, 2 minus, and 14H plus 1. What are my reactants in the other equation? That's 6Fe. It's 6Fe 2 plus. What are my products? The products are 2Cr3 plus and 6Fe3 plus and 7H2Os. You don't write the electrons because the electrons are going to get cancelled out. the number of electrons being gained and the number of electrons being lost would become equal. So that's your overall equation now. Is this clear, this thing? Yes or no, is this clear? Hani, is this clear, Amna? So the whole point was when you have a redox equation, the reason why, because the whole question actually depends on this equation. So we're gonna try and we're gonna kind of try and do this question, just try and do this question. Remember, the redox equation part is a small part, but it's an important part because the whole question depends on that. So let's start with the first part, that there's a 3.35 gram piece of wire. And the wire is made up of iron. You have to find the percentage of iron in the iron wire. So sketch what's going on. 3.35 grams. You can always sketch, make a rough sketch of Fe. Not Fe, iron of an Fe wire. Plus it's going to have a lot of impurities as well. You want to figure out the percentage of Fe. And then he says that it reacts with dilute sulfuric acid in the absence of air so that all the iron atoms are converted into Fe2 plus ions. So he dissolves it in sulfuric acid. So he dissolves it in sulfuric acid, adds H2SO4, and makes it a 250 cm³ solution. And he says that all of them, they get converted to Fe2 plus ions. So he's asking for the equation. The equation is that there's Fe reacting with H2SO4, and it will be converted into FeSO4. It will be converted into FeSO4 plus hydrogen gas is given off. I said, but anyways, you got a 250 cm³ solution that contains Fe2 plus. Now 25 cm³ sample of this solution. So he takes 25 cm³ of this solution that contains iron 2 plus ions. So the solution contains iron 2 plus ions. And it's titrated with potassium dichromate 6. So from the top, he adds your Cr2O7 minus. So he's adding Cr2O7 minus. And that requires the concentration and volume is given. So can anyone find the moles, like how much Cr2O7 is being used? What do we get? So the entire question is you took an impure wire, dissolved it in H2SO4, and it got converted into iron 2 ions. So you got a solution that is 250 cm³ iron 2 ions. You took 25 cm³ of that solution, which contains iron 2 plus ions, and reacted with Cr2O7. And he gave you the concentration and the volume. Tell me what the moles are. What's the formula of moles? It's concentration times volume. Can you even quickly tell me what are the moles that you're getting?
Eight times 10 to the power of -4.
So you're getting 8 times 10 power negative 4 moles. So he's saying the first part, calculate the moles in dichromate 6 ions used. So we did that. And then he's going to ask you to find the moles of iron 2 ions. So what's the ratio? That we just did the equation that iron 2 ions and Fe have 1:6. That's why the equation was important. So if this is 8 times 10 power -4, then Fe would be 6 times that. So tell me how many moles of Fe do you have? So Fe would be 6 times more. You multiply that by 6. So how much Fe are we getting in this solution? Siddha, what's the answer to this?
For FE, right?
Yeah.
4.8 times 10 to the power of -3.
So you get these many moles. And then after that, you found the moles of Fe. He's going to ask you about the moles of iron in the 3.35 grams of the wire. So all those iron moles are over here. So in the 25 cm cube solution that you did titration with, you got this much. So the wire was dissolved in this 250 cm cube solution. So you're going to use ratios that in the tiny 25 cm cube sample that you did titration with, you found out that you had 4.8 times 10 power minus 3 moles. The original solution was 250 cm cube. So how many moles of iron were present in that original solution? That's going to be 10 times that, right? I mean, you can cross multiply. And this would come out to be 4.8 times 10 power minus 2 moles. Is this clear? Because you found the moles in the 25 cm cube sample, and now you're being asked to find the moles in the 250 cm cube sample. So that's going to be 10 times more. Is this clear? Yes or no? Is this all clear?
Yes.
अच्छा, और फिर ये कि now he's asking to find the mass of iron. Now these are the moles of iron in the solution. They all came from the wire. So what's the mass of iron? Mass is moles multiplied by the AR of iron. So that's 55.8. So what do we get for that?
$0.26784.
2678. So I'm going to just stop at 268 grams. 3 significant figures. I should make this as 4.80 as well. So I'm going to get 0.26, and the last part is percentage of iron. So what was it was a 3.35 gram piece of iron wire. So find the percentage. That's going to be that you're getting 0.268 grams of iron when you had dissolved a 3.35 gram in a 3.35 gram piece of wire. You multiply it by 100 and you're going to get the percentage, which is going to be what?
$0.08.
Into 100, that's can't be 0.08. Are you sure we?
8.
You're getting 8.00 or what?
No decimals.
So 8.00%. Make sure it's accurate up to 3 significant figures. I'm just assuming that this is a very small value, which might be some. But I think it's going to need 0.8%. 1 second, let me quickly do this. Just 1 second, 4.8. E minus 2, and that's multiplied by 55.8. That gives me, there's actually something wrong. This is not 0.268 grams. So that, can you double check this? This is this is coming out to be 2.6784 grams. So I can write that as 2.68 grams. And this over here would be 2.68. So 2.68, divide that by 3.35. And I get this, and I multiply it by 100. And I'm getting 79.95%, which is basically around 80%, 0%. Okay, so there's a factor of 10 that's missing. Make sure you add that. You add 4.8 times 10 power minus 2 moles. Okay, is this clear? So let's continue tomorrow. We'll try and do more redox and moles questions, and then we'll just leave moles for now. Okay, we'll move to the next topic after that. Probably the last class on moles would be tomorrow. So, everyone. Okay, take care. Allah Hafiz.